So my second derivative is x squared minus 9 quantity squared times 4x cubed minus 54. That's not enough room. I'm going to have to pull it down here to write just because I need to. I know this is exciting for y'all to watch. Okay, so here's my derivative. It's the denominator, x squared minus 9 quantity squared, times the derivative of the numerator, 4x cubed minus 54x, minus the numerator, x to the fourth minus 27x squared, times the derivative of the denominator. Again, that's a chain rule. 2 to the front, x squared minus 9. You subtract 2 from 1 and you get 1. And then the derivative of the inside is 2x. And then that's all over x squared minus 9 quantity squared. Okay, so with this, now to the fourth power, because I'm squaring it. All right, so now from all of this, I can factor out an x squared minus 9 from this binomial in the numerator. And I'll be left with x squared minus 9 times 4x cubed minus 54x minus, okay, I've pulled this out, so it's going to be 4x times x to the fourth minus 27x squared. And that is all over x squared minus 9 to the fourth. Okay, at this step right here, this will cancel out with one of those. Now, just distribute right here. X to the second times 4x cubed would be 4x to the fifth. All right, and then we get minus 9x cubed. No, minus 36x cubed. Minus 54x, that's minus 54x cubed. And then 9 and 54, 486. Glad I picked an easy problem. And then it's minus 4x to the fifth. And then 108 x cubed. That's going to be all over x squared minus 9 quantity cubed. All right, so cleaning up, and this will frequently happen, you'll have some terms just outright cancel out. All right, 36 and 54 is going to be 90, negative 90. 108 minus 90 is 18, so I have 18x cubed. Let me double check that arithmetic. All right, that's 90. Yeah, okay. And then plus 486 x, and it's all over x squared minus 9 cubed. Okay, now I get to this point, and I want to take 486 and divide it by 18, and hopefully it will. I think it will. I know it divides by 9, but I think it divides by 18 as well. 486 divided by 18 is 27. So if I factor out an 18x, I'm left with x squared plus 27. All right, that will not ever equal to 0. And then in the denominator, I get x squared minus 9 quantity cubed. Okay, so setting each part equal to 0. Again, these are defined your potential points of inflection. You get x equals 0. Now, again, this would not equal to 0, but you still have the potential of changing concavity at plus or minus 3. And it probably will this time because this is an odd exponent. But let's see what happens here. Number line, -3, 0, +3. Okay, so from here, -4. All right, that's going to be a negative times a positive, which would be negative, divided by a positive. So it's going to be negative, so it's going to be concave down. All right, -3 to 0, so plug in -1, negative, positive, negative, negative over negative is positive, so concave up. All right, at +1, it's positive, positive, divided by a negative. So it's going to be concave down. And then finally at 4, positive, 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 concave up. So, next thing I want to do is I'm going to erase all of this so I'll have room to do my graph. But I'm going to also make a chart here. And I will hold up and do the chart on the next video.